In this video, we're going to be solving an application involving inverse variation. In an example we have here, it says the loudness of sound measured in decibel levels varies inversely as the square of the distance between the listener and the source of the sound. Now, if the loudness is 17.92 decibels at a distance of 10 feet from a stereo speaker, what is the decibel level 20 feet from the speaker? So we're going to define a few things. So first of all, we're varying inversely. So we're going to be using some division. We're going to let L equal the loudness of sound in decibels. And we're going to let D equal the distance in feet. So to write our model, we're going to have that L is our 17.92, and our 10 is our distance that we're going to use. So to write our model, we have L equals K, our constant of variation, divided by our distance squared, right? So varying inversely with our distance squared. Now we can take our 17.92 and our 10 feet, and we can plug those into our equation. And let's go ahead and simplify 10 squared is to 100. And now we're going to go ahead and we're going to get that K value by itself. So we're going to multiply both sides by 100 here to get rid of that. And we're going to get that K is going to equal 1,792, which means that our model is going to look like L equals 1,792 divided by the distance squared. And so now we can plug any distance we want into that and find what that decimal level is going to be. So L equals 1,792 divided by, and it asked us about 20 feet. So we're going to plug in that 20 feet. So 20 squared. And when we plug that in, we're going to find that we have an L value of 4.48 decibels. So we write our model, then we solve for the constant of variation, plug that into our model, and then use that new model or that new equation to solve our question that's being asked. Now notice that the loudness of sound is 17.92 decibels at a distance of 10 feet from the speaker. When the distance from the speaker is increased to 20 feet, the decibel level decreases to 4.48 decibels. And this is consistent with an inverse relationship. For our K values that are greater than 0, as one variable is increasing, the other is decreasing. And it also seems reasonable that the farther one moves away from a source of sound, the softer the sound is going to become.